Hey guys, it's Miss Smith. We're going to be doing squares and square roots tonight. Okay, starting off, you just took a square root test. So, y'all should know exactly what square root, or squares are. Sorry, you just took a squares test. You should know what squares are. Let's start off with what are square roots. Well, they're the opposite of perfect squares, which you just took a test on. So, really fast, 7 squared is 7 times 9, which equals 7 times 7, which equals 49. 18 squared, or 18 times 18, equals 324. Okay, so all square roots are, it's the root of the number. So taking the square root of 49 would equal a perfect 7. Taking the square root of 324 would equal a perfect 18. And we call, this is a variable, so you can put any number in this, the square root of x is called a radical sign. Alrighty, so looking to the left, let's start with the left here. Okay, principal square root is a square root of a positive number. So if I have the square root of 225, positive, I'm going to come out with 15. Or 15 squared equals 225. So that is a principal square root. Alright, looking at negatives. I'm going through this fast because it's pretty easy. It means your answer is going to be negative. So if you see that negative sign in front of your radical, so if I have negative square root of 36, that's going to equal negative 6. Okay. Now, those are pretty easy definitions. Now let's look over here to the right. Okay, perfect square roots, rational numbers. We are going to talk about this whole square on Monday. Okay, but just going over it, non-perfect squares are irrational numbers. Okay, we're going to talk about that Monday. I just wanted to go over it so when we go back to it on Monday, you can remember me saying this in the video. Okay, perfect squares. Perfect squares are what you took on your memorization test on Thursday, okay, or you're taking it tomorrow. Sorry, I'm doing this video early. You're taking your squares test tomorrow. So a perfect square is going to be 8 squared equals 64. Or 12 squared equals 144. Okay? So a perfect square is going backwards of that. Those are perfect squares. Perfect square roots are square root of 64 equals 8. Or the square root of 144 equals 12. You have memorized all the perfect squares up to 21. But what if we had this number? What if we went backwards from squares and we did the square root of 8? Or what about the square root of 102? So this is what we're doing today. We're estimating what happens if they're not perfect. Okay, so that's what we're going to be doing down here with estimating square roots. Okay. Oh, hey, I'm skipping over. Okay, sorry. Let's go back really fast to square roots have two numbers. I'm just going to go over this really fast. I'm sorry, I jumped ahead. Okay, let's go over just square root of 64. Square root of 64 has two answers. I know you're going to think, what about a negative square root? If that has that negative sign, of course it's going to end up being negative. But the square root of 64 can be two answers, and I'm going to show you why from our triangle here, our integer triangle. So if I have 8 times 8, right? This is my square root. Of course, square root of 64 is 8. I can show it in a model form. 8 times 8, which is the same thing as 8 squared, right? If we're finding the area of this. Okay, what about negative 8 times 8? Does that still give you 64? Yes, it does, because our integer rule is correct. So negative times a negative still gives you a positive 64. So in this case, square roots have two answers. And you can see it by these models over here. So I have a little, a little box that you can come back and reference. So area is always measured in square units. That's why we show squares and square roots through area. Area, base times height, or unit squared, or square units. This is all different ways to show area. We'll get to perimeter when we get to these word problems here in a second. Okay. 2. Try this one out. What two square roots could the square root of 25 be? Very good. It could be 5 or negative 5 because of our integer rules. A negative times a negative is going to equal a positive. So we should just notice that positive square roots could have two answers. Okay? Okay, now, what we talked about earlier when I was jumping ahead, when we talk about the square root of 8 or the square root of 102, those are not perfect. You can kind of think of, what was on my squares test? Remember, I made you memorize, or I'm making you memorize that tonight for your square test tomorrow. So this is exactly why I had you memorize this, because you're going to need to, know this in a split second for you to get this, for estimating square roots to be easier and for you to get it done a little bit faster. Okay, so let's look at number 1. Number 1, what if I had this square root of 12? I've wrote all this down for you, so all you got to do is fill in under your radical. If I had the square root of 12, think about two square roots that are before and after it. Okay, in my head I'm thinking about the number 3. Okay, so how would I get 3? Well, the square root of 9. Okay, the square root of 9 is before the square root of 12, and I know that the square root of 9 is 3. Okay, what would be after 3? Well, it's going to have to be a whole number 4. So, how would I get here? Well, the square root of 16 equals 4. So, this is how we estimate. I'm estimating between the number 3 and the number 4 here, because the square root of 12 is going to have to be something between 3 and 4. Hey guys, okay, so I got stopped in the middle, and I got stopped on number 1, and so now I'm back during 6th period while y'all in class today and finishing this up. So I got a little advice on how to fix the notes a little bit so they can go a little bit faster, and it's not so, it doesn't lag, and my hand's not in front of it. So, okay, so we're starting out. We did this one when I wanted to know the square root of 12, so we are estimating. So I need to estimate by knowing what my perfect squares are, which you memorized your perfect squares. So if you know your perfect squares, then you know your square roots. So what I do is I think of whole numbers, 1, 2, 3, 4, 5, 6, 7, and I think of their square roots. So on this one, I'm thinking of something close to 12, so I'm going to think, what is 3 squared? Okay, 9. So that's a little bit above 12, so 9 squared would be a square in front of the square root of 12. Okay, sorry, square root. Square root of 16 is next, so it only can be between 2. So of course my next whole number is 4, so the square root of 16 would be 4. So on my timeline down here, when I estimate in the calculator, it is exactly 3 46/100ths. Now these little squiggly lines mean approximately, but this is the actual number because I put it in the calculator. Okay, so looking down here, the square root of 12 is going to be between 3 and 4. The reason I put it in front of 3.5 is because what is it closer to? Is it closer to 9 or is it closer to 12? And that's what we have to come up with. So between these two, we're about 3 away. And between these two, we're about 4 away. So it's going to be closer to the number 3. So that's how we got that. Alrighty. So the next one. On number 2, I'm going to zoom in a little bit. On number 2, we have the square root of 26. So in the calculator is approximately 5 1/10. So that's it. It's exact. I know it's in front of the approximate, but that's it. That is it's exact. So the square root of 25 is 5. So I think of numbers. What would 26 be between? And it's going to be between 5 and 6. So it's all about estimating is all about knowing your perfect square roots. So on a number line, square root of 26 would be between 5 and 6. Why do you think I chose the square root of 26 closer to 5? Exactly, because it's 1 away. So that is a lot closer than being 10 away from 26 to 36. That's a lot closer from 5 than it is 6. So that's why it's very close to 5 here. Everybody with me? Okay. So estimating, we're going to estimate on number 3, we're estimating the square root of 114. In my head, you got to come up with what two numbers would it be between. Square root of 100, I came up with because I was thinking about 10. 10 squared is 100, square root of 100 is 10. So it has to be between 10 and 11. And then on my number line, I have between 10 and 11 here. So this is between the square root of 100 and the square root of 121. So why do you think I put it over 10.5? Very good. Because it is a little bit closer to 121 than it is to 100. Because 121 is it's closer than 14 away here. Alright, now put it in the calculator. It's approximately 10 and 6800ths. Alright, we will definitely go over this in class, so no worries if you don't get it, but I'm going to move on for time's sake. So let's go to number 4. Alrighty guys, I'm going to go back. I can't remember earlier if I went over area and perimeter, but okay, think about it. Squares and square roots, when we have a square as a shape, right? When we have a square shape, all our sides are alike, correct? We have equivalent sides. So this means that if I know the area of that, of course, look at, I'm not going to move it up, but look at your area. It says area is units squared. So that means whatever my side length is, I'm going to square it. So in order to find the side length, I have to make sure I take the square root of it. But what if I don't have a perfect area, right? Where I can't get a perfect square root from it. So here, I estimated that it was between 11 and 12. Okay, now I'm writing this on here, guys, but you're going to have to make sure that, you know, when you do this by yourself, it's not already going to be here because we're doing notes a little bit differently, but we'll definitely go over tomorrow, but you're going to have to come up with those two numbers, just FYI. So maybe go ahead and pause me and do 5 and 6, and let's see if we get the same answers, since I already have the notes and I'm going kind of fast. Okay, so my side lengths would all be 11 and 8/10, and you know, one of my side lengths would be 11 and 8/10. Okay, number 5. Sammy's garden is shaped like a square. Okay, so we know all sides are equivalent. And has an area of 320 feet. So if my area is 320 and I want to know the side length, well, I just need to estimate the square root of the area. So I'm going to estimate the square root of 320. And when I'm thinking of my perfect squares, I come up with it's between 17 and 18. So it's a lot closer. It's 4 away from the square root of 324. So that's how I know I'm gonna estimate pretty close to 18. So it might be 7.8. Oh, it actually is 17.88. But I would, before I just looked down, I would have estimated 17.8. So that's the side length of that. Okay, next one. Pause me and try to do this one. This one's a little bit different, but I think you can do it. Alright, so hopefully you pause me and let's see if we get the same answer. Okay, the area of a square is 51 meters. So we know the area, and in order to find a side length, since all are equal, and area is, you know, s squared, side squared, then I can find my side length by estimating the square root of the area. So estimating here, I know it's between 7 and 8. It's a little bit closer to 7, so I'm going to estimate closer on the side, on the number line of 7. So I end up with 7.1 if you wanted to, but it's exactly 7 and 14 hundredths. But the question asks about perimeter. So it's not asking about the area or just the side length. It's asking about the perimeter. So if we know the side length, we have all our sides. So in order to find perimeter, you should have it up here at the top of your paper. You add all the sides together, and I got 28 and 56 hundredths. Alrighty, that's it. If you need to go over the video or rewind, fast forward, go for it. I'll see y'all tomorrow.